In this video, we are going to do some graph interpretation of trigonometric graphs. So, we are given two graphs. It says consider the graphs of f of x equals tan x minus 1 and g of x equals cos 2x for x is an element of negative 90 degrees to 180 degrees. So if we look at the graph, it's not indicated on the graph which graph belongs to which equation, but that we can work out because of our knowledge of tan and cos graphs. So the orange graph is our tan graph, which is f of x, okay? And just remember that every tan graph has asymptotes, and there is clearly an asymptote at 90 degrees and at negative 90 degrees, okay? So then the other graph must be our g of x, the cos graph, okay? Now, the questions say determine the values of x for which, and number one asks where tan x equals cos 2x plus 1. Now, we were given f of x and g of x and their diagrams to work with. So somehow this must relate to those two graphs, okay? So if we look carefully, f of x had tan x minus 1. So what I have on the left-hand side here is tan x, and if I were to subtract this 1 and bring it to the other side, I would end up with tan x minus 1 equals cos 2x. So this tan x is clearly now f of x, and the cos 2x is g of x. Okay, so we need to then understand what does it mean if f of x equals g of x. And from our years of graph interpretation, you should recognize this as the points of intersection. So what we need to answer with are the values of x where these graphs intersect. So looking for the points of intersection, there is only one point at which these graphs intersect. It is at the 45-degree angle, and we only need to answer with the x values. Okay, so our answer to number 1 is x equals 45 degrees. Looking at question 2, we have 2 cos x all squared minus 1 equals 0. Now somehow this must relate to the graphs that we are working with, okay? But the form here is very different to what we were given. So 2 cos x squared minus 1 clearly does not easily relate to the tan x. So the clue is that it must somehow relate to g of x, okay? Now from our knowledge of double angle formulae, you should recognize this left-hand side as a cos double angle expansion. Cos 2x equals 2 cos x all squared minus 1. Okay, so what this is actually saying is where cos 2x equals 0. Cos 2x was g of x, so this is where g of x equals 0. So if we let the y coordinate be 0, what are we looking for? We are looking for the x-intercepts of the graph. So we want the values of x for the x-intercepts of the g of x graph. So I have an x-intercept at negative 45, at 45, and 135. So the answers are x equals negative 45 degrees, 45 degrees, and 135 degrees. Okay, sticking to the same graphs, we continue our questions, and we are asked to determine the values of x for which f of x is less than or equal to 0. Now remember that this is f of x, and here we have g of x, okay? So f of x less than or equal to 0 is indicating where the y values are less than or equal to 0, okay? Where are the y values less than 0? That's negative. It's below the x-axis. So for these questions, we use our knowledge of the y coordinates to find the part of the graph that we are interested in, okay? F of x is below the x-axis on that part and this part, okay? And we need to remember that f of x had asymptotes, okay? So at negative 90 and 90. Okay, now we use the y coordinates to find the correct part of the graph, but we answer in terms of the values of x. So to find the values of x, we would draw vertical lines And that's how we would read off the x coordinates of these parts of the graph. Okay, so that's one part and the other part here. Okay, so there are two sections in this answer, which means we will have two inequalities in our answer. So the first inequality are the x values that range from negative 90 to 45. So these x values. Okay. Now, negative 90 is the value of an asymptote. Okay, so let's just write negative 90 degrees. X lies between negative 90 and 45 degrees. It's always less than, less than. What we need to decide is, do we include these values? Now, the only reason we would include is because f of x is also equal to 0. Okay, so at negative 90 degrees, there is an asymptote. So it's undefined, we cannot include it. But at 45 degrees, that is where y equals 0, which is what we were also looking for. So we will include the 45 degrees. That's the one part of the graph. The other part that was applicable, the lowest value is 90 degrees. And it continues to, now here we were given a domain. Okay, so our graph is literally what we see here. It doesn't go off into infinity. So this second section that was applicable to this question starts at 90 degrees and goes to 180 degrees. Okay, now what is happening at 90 degrees? We have an asymptote. What is happening at 180 degrees? Our y value is about negative 1. So it's not equal to 0. So we write x between 90 degrees and 180 degrees. We won't include the 90 degrees because it's an asymptote there. And we won't include 180 degrees because that's not where f of x was equal to 0. Okay. Looking at question 4, we want the values of x for which g of x is greater than 0. Greater than 0 means where the y values are positive, which is above the x-axis. So we use the y coordinates to locate that part of the graph. Now g of x was our purple graph. So let's just highlight the part of the graph that is applicable. Okay. So g of x is above the graph here and there. Okay, so now we want the x values. We answer in terms of the x values. So vertical lines down, and we have two parts of the graph. Okay, so two inequalities in my answer. My first answer, the x values range from negative 45 to 45. The second part of my answer will be that the x values range from 135 to 180. Okay, so negative 45 degrees to 45 degrees, x lies between them. It's always less than, less than. Okay, we don't have to consider whether they are included or not because we're not interested where g of x is also equal to 0. Okay, that's one part of the graph. The second part that was applicable range from 135 degrees to 180 degrees. X lies between them and it's less than, less than. Okay, still with the same graphs. This is g of x, this is f of x. Okay, determine the values of x for which f of x is greater or equal to g of x. This is asking whether y values of f are bigger than the y values of g of x. So it's where f of x is above g of x. Okay, so we use the y values to understand which part of the graph we are talking about. So f of x is above g of x only in this green section. Okay, so we found the correct part of the graph, and now we answer in terms of the x values. To find the x values, we draw vertical lines down. And remember that at 90 degrees, we had an asymptote. So the part of the graph won't go beyond that 90 degrees. Okay, so our x values then range from 45 degrees to 90 degrees. So 45 degrees less than x less than 90 degrees. Now here we also had that f of x could equal g of x. So we would include any points of intersection, and the 45 degrees was a point of intersection, so we will include that. The 90 degrees was an asymptote, so we do not include that. Right, question 6. Now we want the values of x where f of x is less than g of x. Okay, so this is where f of x is below g of x. So we use our y values to find the correct part of the graph, and this is where f of x is below g of x, and this section of the graph here. Okay, so we answer in terms of the x coordinates. So vertical lines to the graph, okay, indicates where we would find the x values. And remember, at negative 90, we have an asymptote and it would stop there. Okay, here, 180 degrees applies. The x values are found here until we get to the asymptote at 90 degrees. Okay, so 2 parts of the graph and our answer. So the first part, we answer in terms of the x values. They range from 90 degrees to 45 degrees. So x lies between, sorry, that's negative 90 degrees and 45 degrees and less than. We don't include them because we're not interested in where f of x was equal to g of x. Okay, so that's the first part. The second part, the values range from 90 degrees to 180 degrees. So x lies between these two values and it's less than. Question 7, where f of x is greater or equal to negative 1. Okay, so I think let's just clear up our diagram quickly. Now looking at question 7, f of x is greater or equal to negative 1. Now this is asking for the values of x where the y value of f is greater or equal to negative 1. So if we look at the graph of f of x, which is the orange graph, okay, the part of that graph that has y values greater than negative 1 is this part, okay? That's the only part where the y values are greater than 1. So we need the x value. So we find the part of the graph, you're looking at the y coordinates, but we answer in terms of the x coordinates. So to do that, we would draw vertical lines to the x-axis from that graph. Okay, remembering that at x equals 90 degrees, we have an asymptote. So our x values range from 0 degrees to 90 degrees. Okay, now we are also interested in where f of x is equal to negative 1. So the x value where f of x is equal to negative 1 is 0. So we're going to include the 0, but we're not going to include the 90 degrees because that's an asymptote. So our answer here, x lies between 0 degrees and 90 degrees. We include the 0, but not the 90. Looking at question 8 now, it says we're still determining the values of x for which, and now we look at where f of x times g of x is greater or equal to 0. So what we have here is a product of the y values. So the product of the y values must be greater than 0 or equal to 0. So we must get a positive product, okay? So when do we get a positive product? It's either when we have a negative times a negative, or when we have a positive times a positive. Okay, so when do we have negative times a negative? That is when both the graphs lie below the x-axis. Okay, so if we move from left to right, okay, where I'm going to highlight points where both our graphs are either below the x-axis or both above the x-axis. Okay, so from the negative 90 to negative 45, my f of x, sorry, this is g of x, and this is f of x. Okay, so from negative 90 to negative 45, g of x is below the x-axis, and f of x is also below the x-axis. So its y coordinates for both of these parts is negative. So negative times a negative gives us a positive product. Okay. Now, after negative 45, g of x is above the x-axis, which means it has positive y coordinates, okay? And between negative 45 and 45, f of x has negative y coordinates. So the product of these y coordinates would be negative, which is not the part that we're interested in, okay? After 45 degrees, after 45 degrees, f of x has positive y coordinates, but then g of x has negative y coordinates, okay? After 135 degrees, from 90 to 135, both graphs have negative y coordinates. So negative times a negative gives us a positive product. So we would include these x values. And after 135, the y coordinates of g of x are again positive, while those of f of x are negative. Positive times a negative gives us a negative product. Okay, so we answer in terms of the x coordinates. So the parts where we got a positive product were negative 90 to negative 45, okay, and between 90 and 135, okay. Now the part that I have not focused on yet is where the product is equal to 0. Now the product will be equal to 0 if one of the y coordinates is 0. So any point where the graph lies on the x-axis, we would have a product of 0. So that's at negative 45, at 45, and at 135. So we must remember to include those values. Okay, so negative 90 degrees, negative 45 degrees, x lies between them, and we will include the negative 45. Okay, then I have the 45 degree angle. So x at 45 degrees, that's where the product would be 0. Okay, and then again between 90 degrees and 135 degrees, we have a positive product. At 90 degrees, I have an asymptote, but at 135, my product is 0. Looking at question 9, we have where f of x times g of x is less than 0. So now we are looking at where the product of the y coordinates is negative. So that would be everywhere where it's not positive, right? So from negative 45 to 45, I have a negative product of the y coordinates. So positive times a negative gives me a negative, okay? At 45, the product was 0, which we don't include. But after 45, again, up until 90 degrees, my product again was negative, okay? After 90 to 135, the product was positive, but after 135, I again have positive times a negative, which gives me a negative product. So I have 1, 2, 3 parts of the graph, which means I need 3 inequalities. So the first part, I'm just going to write number 1, okay, runs from negative 45 degrees to 45 degrees. X lies between them, and we don't include those because at those points, the product would be 0, okay? Then the second part runs from 45 degrees to 90 degrees, okay? We don't include them because 90 is an asymptote, and at 45 the product would be 0. Then our third part is from 135 degrees to 180 degrees, and we don't include those either. Okay, question 10. G of x minus f of x equals 2. So that is asking where the difference in the y coordinates is 2, okay? So a y coordinate on G minus a y coordinate of f must give us a length of 2, okay? So we must have g of x at the top. So wherever g of x is at the top, where do we have a difference of 2? I have a difference of 2 here, okay? So g of x here, the y coordinate for g of x is 0. The y coordinate at f of x here is negative 2. So 0 minus negative 2 would give us 2, okay? This happens where x is equal to 45 degrees, okay? Where else does it happen? here I have a difference of 2. 1 minus -1 is a difference of 2. That happens at the x-coordinate of 0. So at x equals, sorry, this first one was -45. X equals 0 degrees. So where else do we have a difference of 2? Here, okay? G of x, the y-coordinate of g of x is 0. The y-coordinate of f of x here is -2. So it's a difference of 2. We answer in terms of the x-coordinate, so x equals 135 degrees. Moving on to different types of questions, but we still want the values of x, okay? We want the values of x where the graph of f is increasing, okay? Remember, f of x was our tan graph. So where is it increasing, okay? As we read from left to right, so as the x-coordinates increase, what is happening to the y-coordinates, okay? They are increasing. And then we have an asymptote. But after the asymptote, if we move from left to right, the y-coordinates are still increasing, okay? So wherever the graph is defined, the graph is increasing. So it's increasing for x is an element of real numbers, but x cannot be the values of the asymptotes. And we have an asymptote at -90 degrees and at 90 degrees. Number 2, where is the graph of g decreasing? Remember that this is the graph of g of x, and the graph is decreasing where it is going down as we go from left to right. So the parts of the graph that are decreasing are this part only, okay? So we need to answer in terms of the x-coordinates, so we draw vertical lines down to see where the x values are, okay? And they range from 0 to 90 degrees. Do we include 0 and 90 degrees? We don't include 0 degrees because at 0 degrees the graph has a turning point where it is neither increasing nor decreasing, and that is the same at 90 degrees. So we do not include the 0 and the 90 degrees. Okay, so the graph of g is decreasing where x lies between 0 degrees and 90 degrees. Okay, looking at question 3, we want the values of x for which the derivative of f is greater than 0. Okay, remember that the derivative refers to the gradient. Okay, so where is the gradient positive? And the gradient is positive when we have an increasing graph. Okay, so where the graph increases, the gradient is positive. So where is the graph increasing for f of x? We had answered that question in number 1. So it's increasing everywhere except at the asymptotes, which were at -90 degrees and 90 degrees. Number 4, where is the derivative of g of x less than 0? So this is asking where the gradient of g of x is negative. Where is the gradient negative? It's where the graph is decreasing. So our answer is actually the same as the answer for number 2. It was between 0 degrees and 90 degrees. Right, another type of question says for which value or values of k will y equals cos 2x plus k have no real roots. Okay, so remember that another name for roots is your x-intercepts or points of intersection, okay? And no real roots means there are none, okay? So no x-intercepts. So let's understand this, okay? Remember that we had 2 graphs here. One was f of x and it was a tan x graph, and the other was g of x equals cos 2x. So what we have within this, okay, let me actually just write it here, y equals cos 2x plus k. What we have here is g of x, okay? So if I add k is a constant. If I add or subtract a value, the effect that it has on this graph is that it moves it up or down. Okay, so we want to know the values of k that would cause our g of x function to have no x-intercepts. Okay, so we can see that if we were to shift the graph up slightly more than 1 unit, we would have no, so if we were to shift the graph up by 1 unit, our graph would sit on the x-axis, okay, and have those two x-intercepts or roots. If we were to shift it up slightly more than 1, we would have no roots, okay. So for example here, if it's there, it has no x-intercepts, okay. So shifting it up more than 1 would cause it to have no real roots. But we could also shift the graph down, okay? So if I were to shift this graph down more than 1, the graph would sit there, okay? And also, so if we shift it down more than 1, our graph would also have no x-intercepts. So, shifting the graph up, if k is a value greater than 1, we would have no x-intercepts. Or if k is a value less than -1. Okay, wait, let's just think about this. If I shift it down by 1 unit, it's -1. If I shift it down more than -1, it's -1,5, for example. If I shift it down by 2, I'm shifting it, I would subtract 2. Okay, so the values are -2, -1.5, -1. So these values are less than -1. So that is correct.